All right. So today is February 11th, and so this is the last class before the break. Pretty quiet for us. Although assignment two, of course, is due after the break, so make sure you get a start on that. Um, it does get a little hectic after the break, right? We got a tutorial, and then we got a assignment three and test two due in test two is in the third week after the break. So it's going to be hectic. In hindsight, I may have, well, I can't move the test, right? So this is the schedule we're kind of stuck with. Um, uh, the rule of three, you don't need to, we haven't taken operator overloading. So the rule of two, certainly. Rule of three, but without the assignment operator. Um, yeah, that's sort of the idea. Is that the copy constructor and the destructor should behave properly. All right. Is it cutting? I don't know. Anybody else having audio issues? Okay. All right. Yeah, no questions on the schedule. So last class we were talking about um, encapsulation now. Trying to remember exactly where we left off. Well, let's see. I always looked this up right before, and I can never, for some reason, it does not stick in my head. Okay, yes. Constant objects. All right, so constant objects. That's good. So here, yes, we had made a date class, um, and well, first of all, we observed that the day, month, and year were public in this context, so we could access them, but we couldn't write to them, right? We could only read from them because when I make my date const, all the member variables are also const. Is my audio? Let me double check. Looks looks standard. This is the standard setup that I usually use. Is this, make sure it's on. Yeah, everything seems to be on. Um, all right, so all the member variables of my date class are essentially constant. So that means it's kind of weird now, though. I'm going to make a function call, but inside my function, maybe I make some changes to these member variables. Right? So my D1 cannot be changed, but now I'm calling this function. And so how do I know that I don't change any member variables in that function? Well, I promised the compiler using the const keyword that I'm not going to make any changes, right? And so when I make a function that is const, well, the compiler can look through and check to make sure I don't do anything like this, right? So I can, all right, a couple people with audio issues, but apparently not everyone. Oh, all right, sorry, let me get to the correct place. All right. So in my function that's now const, the compiler can easily go through and verify that I have not done anything like changed the day variable. So here I tried to change the day variable. The compiler gave me an error. So I just get rid of that. And it works fine. And we also talked about how, well, from this print function, I called the get month name function. And so if I do that, then I also have to make sure that this is const, right? Because otherwise I'm violating that promise, that contract. Um, so yeah, now I have a const date and I can print it. So for so let's just see that. So there we go. I made a date, January 1st, 2013. I guess. And there it is. So constructed and destroyed. All right. So what other consequences of that are there? Well, basically, I want to, well, actually, let's look at another case first of all. Let's say date today. Today is what, 2026, February 11th. Okay, this is not a const function. So what happens when I call, or this is not a const object, so what happens when I call a const function on it? Well, it works just fine. So printing today, I get February 11th, 2026, right? So whenever possible, if I can make a function const, I should, because now it's more versatile. So there's a few things that happen. One is that it becomes more, well, it guarantees the integrity of our objects, right? So if I make a date that's called New Year's Day 2026, well, then that's very specifically going to be January 1st, 2026, and we probably don't ever need to change it, so we can make it const. It's also going to help the compiler to make optimizations, right? When I make something const, it becomes read-only, and now I don't have to, right? So we saw a little bit how a CPU works. So when I want to, for instance, do something with the value in a variable, I load it from RAM into the CPU, into a register, and maybe I do some math with it or whatever. Well, if it's not const and some changes are made to it, then I have to rewrite it out to RAM. If it's const, then I can do whatever I want with it, right? I know I don't have to, the value that's still in RAM is going to be still valid after I do all my operations. So I have a lot more freedom. The compiler has a lot more freedom to make optimizations. Your object also becomes thread safe, of course, because it's read only. So it doesn't matter. Nobody's going to make a change. You don't have race conditions. Of course, there is this cascading effect, right? So when I make the print function const, all of a sudden my get month string function also must be const. And if you're playing around with assignment 2 and making functions const, you might see that you have you can go a lot further than that, right? And in fact, sometimes you get to a point where, this const function means that this function has to be const, and then this one, and then you get to a point where you're like, oh, I can't make this one const. So now I have to like roll back all those changes, or think of another clever way to fix it. So it's not always clear, 100% clear which functions can be made const, but in some cases it's easy. So for us, we are going to be so for assignment purposes, there's a few simple ones that you should do. And if you want to do more, that's on you. But in terms of making functions const, my internet connections is unstable, apparently. I guess I don't get good. Yeah, so if you're having issues, sorry. There's not a lot I can do about it. For assignment 2, all your print functions should be const, right? So print does not make any changes. So this is sort of a no-brainer. Any sort of, in this case, this is a predicate. So less than, it simply returns a Boolean. And I compare two dates, and neither of those two dates are changed, right? I'm just reading them and comparing their values. So this is another easy one to make const. Less than equals greater than if you have it. Yeah.
Like void something that with no arguments. But no, I guess the field would change.
Sorry,
Global variable. then any function that takes in no parameter. Const.
Well, so a global function, there's no such thing as a const. So const in this case is referring to, I need to have some state, right? Some variable to make const. So a global function, technically, you would never make that const because it doesn't have any state. It's just, it has some like maybe temporary variables you make, but we don't care about those. They're going to get destroyed. So really a function that we make const is part of a class. And so then even if there's no parameters, we implicitly have the member variables. So yeah. Yeah, I hope that answers your question. Are there other questions? Okay. Yeah, sorry, poor Wi-Fi. I'm not sure exactly what to do about it. Hopefully the recording catches everything. It should catch everything. The other sort of easy points for const is getters. With a little bit of an asterisk there. So these are very simple getters. Get day, get month. I return ints. And always remember that const is now part of your function signature. Oh, not this one. So get day, get month. So now if I compile this, it should compile just fine. Maybe not. Where's less than? Okay, so it compiled and it still runs. So my getters, sort of another easy win. There is an exception. So I'm returning by value. For your getters, you can return by value. Yeah, sorry. Yeah, that's an excellent question. So we're gonna get to that in a minute. But yes, you can actually do that. So the question was, can you overload a const or a function with a const and a non-const version? And the answer is yes. We're going to do that momentarily. So just on the subject of getters again, so here we're returning by value, and I'm not paying too close attention to return values in this class, all right? So there's a lot of sort of subtleties there. Generally, they follow the same rules as parameters, but there could be a few things where things get different. Returning by value for a getter is fine. You can also return by reference. So if I look at my get day and get month function, they don't do anything. Here I take the day variable, I return it by value, which means I make a copy, that copy gets returned to whoever called the function. Same with get month, but get year, I'm returning by reference. Okay, so let's say I tried to make this const. So what is, well, is this okay, or is there a potential problem here? All right, so, well, I mean, let's see what the compiler says, first of all. Compiler says no. Compiler specifically says binding reference of type int reference to const int discards qualifiers. So what can happen is if I return this by reference, well, this is now I actually have a reference to the actual year variable inside my date object. And so somebody who calls this can then make changes to the year. So this violates this const promise. Now this is, I can do this. So now I said, well, this is a reference to a const variable. So now whoever calls this, I will give you the actual reference to year, but it's read only, right? You won't be able to write it. So this is, in terms of a getter, you can do this if I want to make my getter const. But we'll consider that as sort of optional, right? You're free to return by value. If I need you to return by reference, I will explicitly state it. But yeah, questions? Okay, all right, this should compile now. Okay, So the question was, can we overload this print function with a non-const version of the print function? If it returns a pointer, you could do the same thing, right? So this is, let's say I returned a pointer. Pointers are actually, so const, all right, this is very, very, here you can use const just about anywhere. But here what I'm saying is that this is a pointer to a const object, right? So that's what this particular declaration means. So this will work, right? If I return a pointer to an int, as long as I say, well, you cannot change the thing that it's pointing to. I can actually change what the pointer points at. That's okay. So there's a lot of subtleties here. I can also do this, const. Now I'm saying that I think this is correct, but I might have a little bit backwards. I would have to look it up, but I think what this means is that now I cannot change my pointer. So now this is a const pointer. And I think you can even do, I don't know. I'll have to look this stuff up. But there's tons of things you can go with, do with const that we're not going to explicitly cover. After the asterisk. So that means, okay, so this means const pointer, I would assume. And this means const pointer to a const object, and you can actually have double pointers. Bananas. But yeah, so return by value, and you're fine. Yeah.
The object that opens layers of const. Like if you have a pointer field, would you be able to turn that to const through that get year method?
Yes. So it's not a const object, but I'm saying if you use this variable, you cannot modify it. Yeah, yeah. So yes, you can have pointers. So I can have a non-const object and a pointer to a const object that we're actually going to do that actually right now. So yeah. A void function. Yeah. So as long as it's a member function of a class, the promise is that I'm not going to change any member variables. The problem with this, with the getters, is that if I return by reference, now I'm sort of like leaking member variables to the outside world. Does that make sense? Yeah. Okay. Good, good. Other questions? All right. So let's see. We saw that we have a date today, and it can call a const version of print. But let's say that there was some subtle difference in the const and non-const versions of print. And so maybe we want to have both. So I'm going to add a second print function. And we'll just do the same thing, but we'll add an extra line saying non-const version. Okay, so now when we run this code, we print out D1 and then we print out today. We'll see that, well, D1 is still January 1st, 2013. But when I print today, it gives me February 11th, 2026, but it gives me the non-const version of the print. So yes, you absolutely can overload those, and that's very useful in a lot of cases. The best option, or the simplest option, is to not make that function const. Okay, so you don't have to. We're only looking for, again, a very specific small subset of functions to be const on your assignment. Now, if you want to challenge yourself and make a const and see where that leads you, then I would encourage that. But that won't be evaluated that way. You can make that getter the get project, or I forget what it is exactly it's called, but you can just keep that non-const, right? That's the easiest. I don't remember all the ramifications. In my solution, I do not make a const. Just because, well, I didn't want there to be, if I made a const and then I write the test for that, then sometimes I inadvertently make a test that only passes if it's const, right? So I kind of try to do the least amount of consting that is still perfect marks on the prototype. That is to say, I don't actually know if there's a valid way to get that working. Maybe there is. All right. Today print, well, let's say we wanted to print today using the const version. How could we do that? Well, there's a couple of ways. One is date const today. Sorry, it's a date reference. Right, so I can declare a second handle to this variable, but this one now says, well, this is a pointer to or a reference to a const function. Right, so now in this case, when I print today here, I use the non-const version. When I print today here, I use the const version, right? Simply by changing the handle. So yes, and I could do the same thing with a pointer. I could do something like this. Right now, this is a pointer to a const object. And so today is not actually a const object, but when I use a pointer to a const object, we treat it as one, right? So we just have the const version here. All right, questions? Okay, so there's a lot of complexity there. In terms of what actually traces back to marks, again, for that return get project, just make that non-const if you want. If you want to challenge yourself, you can make it const. But things like print statements, getters, and Boolean predicates like less than and equals, those should all be const, right? Those are easy to see that you're not going to have any real ramifications for making them const. All right. So yeah, we can have two versions of a function, a const and a non-const. Yes, and you can't change a member variable in a const function. And here is just sort of the rules that I just outlined for when you're working on your assignment 2, what you should make const. Just go for the easy stuff. And the complicated stuff, you can challenge yourself. You don't have to, though. All right, constant data members. So we've seen date, which we made the entire thing const, but maybe we only want to have certain member variables const. So let's take a look at that and see some of the repercussions for doing that. But let's say that I have a student class. So we've seen, you know, this is stuff we've seen before. We have a bunch of member variables, and then we make a couple students and print them out. So let's jump to there. Segmentation faults, really? All right, there we go. Some old code, I guess, was in there. So yeah, I made my two students, Stu and Amy. They're both in basket weaving. Well, those are just the defaults. They both each have a unique student number. Okay, so well, the thing about a student number, especially at Carleton, is it's forever, right? Once you get assigned a student number, if you leave and come back, you get the same student number. If you come back as an employee, that's now your employee number, right? So once you get assigned a student number, it never, ever changes. And so maybe we want our object to reflect that. So we're going to, well, let's actually, before we give away the entire game, If we look at our student constructor, we're doing things the old-fashioned way, which is fine in this context. It works perfectly fine. But now we're going to make this into a const object. Now, the thing about const objects is that when I create them, I have to assign them a value. So if I try to make this now, I get a whole bunch of, our compiler is so helpful that it gives me all of this stuff. So typically, if you want to figure out what really happened, you would go to the top. That's generally where the most sensible error message will be. Here it says no match for this assignment operator. And so what it's talking about is this one here. And that's really the only error we want. So that's that student CC, line 11. All the rest of this is the compiler looking for other equals operators or assignment operators that will fit the bill, right? So it's looking in all sorts of classes but basically all of this is sort of useless. The error message you should be looking at should be really the first one, right? That's where you're going to find the most useful information. So I'm not allowed to do this because if we recall, number is a statically allocated member of student, which means that before it's constructed first, so before I even enter this, number is assigned some value. In this case, it's the default value of an empty string. And then when I try to reassign it a value here, it says, well, I can't do that. This is a const member variable. All right, so that's troubling, but not completely unsolvable. We know how to grab a member variable and pass it an argument the first time the constructor is called. So when this number is constructed, it gets this value S1. We're using the member initializer syntax again. And now everything works just fine, except now Stu and Amy, these student numbers are locked in. We cannot change them. All right, questions? Okay. Well, let's do something. Let's do this. So here I declared a student called Cindy. Now Cindy gets the default constructor called on her, which means that Cindy is a fully fledged student object, has all member variables assigned values, including student number. And then I do this. Well, what's the problem? Well, the assignment operator by default is going to try and take Amy's number and assign it to Cindy's number, but these are both constants. I cannot actually change Cindy's number. So if we look at the new constructor signature with default values, the default values, nothing will change about the default values. Okay? So I can still assign default values here. That just means the default value will get passed into the number. But yeah, the other problem is, of course, when I try to do this, it's going to try to assign Amy's number to Cindy. And when I make it, well, actually, again, scroll to the top. So here's the top. Here is the useful error message. You tried to use a deleted function, right? So this is the assignment operator function, and it was deleted, right? As soon as I made the student number const, the compiler deletes this function. And why? Because it doesn't know how to do what you're asking it to, which is, I'm trying to make a copy of Amy into Cindy. However, I cannot change Cindy's student number, right? So the compiler just gives up and says, well, this is too complicated for me. If you want to write an assignment operator function, you can, but the one that I normally give you is going to be deleted. Okay, so that's one sort of side effect of doing this, is that you have that deleted, which may or may not be a huge problem. Sometimes you delete these, sometimes you want them to be deleted, right? You don't want any sort of weird side effects of people making copies of your stuff. But it also brings up another issue, right? Like I follow some tech people online or go to like I used to go to Stack Overflow conversations and things like that. And like, there's an argument to be made that you don't ever need to do this, right? This is already private. Already I control who gets to change it. So, yeah, this is maybe overkill. And it also has, comes with other repercussions, right? Like I can't actually make a copy now, even if I want to. But yeah, questions? Okay. So yeah, so apply the principle of least privilege, consider the data members you create. If they'll never be modified, make them constant. Well, I would put a big asterisk there, and that opinions vary on that, right? So maybe you don't need to make any member variables constant. Just know the consequences. Of course, if you do make them constant, you no longer get to do this for free. You have to write your own and figure out how you're going to copy a student number into another student number. So member initializer syntax review. So we've seen it solve a bunch of the problems that we've had, in particular with encapsulation and const. But basically, between a constructor of a class, between the parameter list and the body, I put the member initializer list. I can use it to initialize anything, but if I have a constant member variable, then I must initialize it using the member initializer syntax. I can also use it to pass parameters to member variable constructors. And if I don't have a default parameter, then I must use member initializer syntax as well. Or sorry, if I don't have a default constructor, and can often result in an empty constructor body, which is perfectly fine. All right, so that brings us to, so we've seen constant objects, we've seen constant functions, we've seen constant member variables. Now we're going to get to constant parameters. And this is also going to solve this problem that we've had with assignment 1, where I tell you that you should pass all objects by reference except for strings, like because that will cause problems, right? So this is kind of something you don't want to do. But now we're going to see exactly why. And we're going to see that actually if we do this, this is sort of the most effective way to pass strings, generally speaking, depending on what you want. So constant, yeah. So here I have an address, and I have a student, and I have a set name function. So we're going to focus on that for the time being. This set name takes a string passed by value, and where is it? It's right there. And it doesn't do anything special. I pass in this string by value and I assign it to the name parameter, or the name member variable. And so in my main function, I'm going to make a student called Stu. I'm going to change their name to Joe, and I'm going to print them out, and we'll do all of this other stuff later. All right, so yeah, just make a student Stu, change their name to Joe, print them out. Okay, well, Stu, we didn't give them any address variables, so we got all the default ones. But we print out Stu. Then we change the name to Joe, and we print out Joe. Everything looks fine. Okay, so well, this is passed by value. We typically want to pass by reference, so let's change that to be passed by reference. All right, that's good object-oriented programming. Well, we have a problem. So let's go to the top again, which is here. Cannot bind non-const L value reference of type string reference to an R value of type string. In other words, well, if we look at what happens here when we make this call, well, Joe is a string literal. Joe exists in the data segment. All string literals are immutable. They cannot be changed. They're R values. So when I passed by value, what happens is, well, it takes a string, but it makes a copy. So it copies Joe into this new string, and then I'm free to use the new string in that set name function, and I copy it into the name. But now when I'm passing it by reference, well, the compiler says, you know, it wraps it lightly in a string variable, but it's still, the pointer is to this Joe string literal, which is immutable. So really, to make a string out of Joe, I need to make a const string. So this set name string by reference, technically I could, by calling this function, I can make changes to this variable n, but that would violate, you know, that would make changes to Joe, which sort of violates Joe's access modifier, or not access, but const modifier. So, well, the solution is just to do this, to say, again, well, I promise, you know, you're passing in a string by reference. I promise that I will not make changes to that string. And then, well, then this should work. All right, so it works the same as before, even though it's super ugly and poorly formatted, but the name has changed from Stu up here to Joe down here. There was I guess let's back up a second. I could also do this, right? Here's another solution, but it's kind of awkward. String name equals Joe. Well, now I have this is a mutable string, so I can pass that in by reference. This is again kind of inefficient though, because I'm making a copy of Joe, but it does sort of solve that problem of the syntax, not of the making of the copy of. But even better than this is, of course, just make this const. And then, right, I'm only just copying this into a member variable anyway. I don't really need to change this, so I just make a const. Good questions? Okay, so for assignment 2, essentially all of your strings passed by value should now look like this. Oops. All right, it's a little bit uglier, but in terms of what actually happens when I compile and run this, it's a lot more efficient. All right. Okay, so Stu changed his name to Joe. Stu is now going to move to a new address. So student now has this move to function that takes an address. Address is an object. I pass it by reference like I'm supposed to, right? That's so good for me. And then in my move to, I just take this address and I copy it into home address using the assignment operator. And then let's make sure that we print Stu out. So Stu is going to move to somewhere. He's currently homeless, but we can see that Stu now moved to 123 Main Street, Montreal, Quebec. Okay, well, this is kind of a little bit awkward because I've had to make this temporary address object. And maybe I don't want to do that. That seems a little inefficient to me. Maybe what I want to do is similar to what I do with string literals. I want to do like an address literal, right? So I'm just going to pass that in. So I'm just going to make a temporary address object on the fly as needed and pass it into this function. Okay, well, cannot bind non-const L value to an R value, right? So this is an R value, and I am trying to pass it in as an L value. This is a modifiable address. So, well, the solution is again the same. I only want to make a copy of this. I do not need it to be modifiable. I don't need an L value. R value is fine. So I'm going to just add the const qualifier. And now, if I want to do it this way, I'm still free to do it. That'll work. But I can also do this, which is, kind of slightly more efficient. All right, so then Stu moves to 123 Main Street. And again, I can't remember all of the tests that I wrote for assignment 2, but I'm pretty sure I do something like this. So if you pass by reference, it'll give you an error unless you make a const. If you pass by value, it will work, sort of, as long as your copy constructor is written correctly, but then that could introduce a whole bunch of other problems. All right, questions? Okay. All right, so those are all the const things, or at least the ones that we are concerned with. Again, you can play with pointers and double pointers and where you place the const, and there's a whole kinds of things you can do. We're not super worried about all of those small details. R value is essentially a constant, but it's sort of more than just a constant. It's any value or temporary object that we're not allowed to change the values of, right? So again, a good sort of, let's say I have A equals B. Those are two variables. Well, if they're variables, they're both L values if they're not const. But if I write something like this, well, that's going to return A plus B, which is an R value, right? This can only be the right-hand side of an assignment operator. So I can write something like this, but I can't write something like this. So this must be the right-hand side of a assignment operator. Could be a const object, could be a value, could be a temporary object returning by value, or passing a parameter by value, any of those things. But essentially it means it's another way of saying const, essentially. Or at least that's a good way to think about it. All right, other questions? Okay. All right, so that brings us to friendship. So we've learned all about encapsulation, how to keep things safe, and now, well, we're going to break all those rules. C++ is like this Frankenstein monster of all of these changes that happened since the early 1980s. And I feel like friendship is one of them. I feel like if with Bjorn, the guy, the head C++ guy, I feel like if he could go back and change these things, he absolutely would. But once an API goes public, it's there forever, and that includes your language. So friendship is still part of the C++ ecosystem. Basically, a class, right? So classes, global functions don't have access modifiers. They're all public. But a class does have layers of access, right? So private, protected, and public. If a class declares friendship to something else, that means that you can access my private and protected member variables. Okay, that's basically what it means. So we might want to grant friendship to a function, that's fine, or another class, or a member function of a class, although I've not tried that one myself. A couple of key things about friendship: it can only be given. You can never demand it or take it. So I can declare that, if I'm class A, I can declare class B as my friend. That means class B can access my private member variables, but I can't access class B's private member variables. I've only given away friendship. So if A grants friendship to B, that does not mean that B grants friendship to A. It's also not transitive, right? So if A grants friendship to B and B grants friendship to C, that does not mean that A grants friendship to C. It has to do it explicitly. Should only be used in very specific situations, although when we get to operator overloading, you'll see that it's completely necessary. But also there are some instances where we want classes to work extra close together, right? C++ we use for efficiency. So sometimes this can be useful. is that we really want these address and student to work closely together. All right, so let's see. So here's my address class. Again, just a regular entity class with a bunch of information and a print. My student class, we have a move to function, which we'll get to, but otherwise, it contains an address, as we saw. Home address or address still gets to keep its private member variables private from student. But let's say that, yeah, all right. So we'll make students Stu and Joe and print them out. And then take it from there. Right. This generally means it cannot find the function definition. So this is often a linking error. But sometimes it means you didn't compile your source code. But student Stu lives in Moncton, New Brunswick, and Joe, well, Joe is homeless. But we're going to have them both move their city and province. So we have this move to function. We're going to move Stu to Vancouver, BC, and Joe to Montreal, Quebec. And if we look at the implementation, well, it's not implemented. I could make setters for my address class, right? So that would be one way to do it. But setters are public, and if I make a setter now, everybody has access. So in this particular use case, I do not want to make setters. I only want the student to be able to change the address class. So what I really want here is home address dot city equals city, and home address dot province equals province. Of course, this will not work, right? We've violated encapsulation, and it says here, you know, city is private within this context, and so is province. Fair enough. All right, so we're going to say as the address class, student class is a good friend of mine, so we're going to allow this. And let's get rid of this guy for now. Okay, so now the compiler sees this and says, well, if I see a class called student, I'll know that this is a friend. Now when I compile, they move, but I didn't print them out. Let's print them out. All right, so moving the students. After the move, Stu is on 123 Main Street in Vancouver, BC. So crazy, he found the same address, but in a new city. Joe moved to Montreal, Quebec, but Joe is still homeless. But so they both managed to move. We granted friendship. That worked fine. Questions? Okay. Well, let's see this other example, this where function. We take a student object, and in this class or in this function, here's what we want to have happen. So student found in stu.homeaddress.city. Now we know that home address is a friend to Stu, but let's see what happens when we compile this. All right, well, probably to no one's surprise, that doesn't work. So it says student home address is private within this context, right? So that means, well, so the problem is that home address is private to students. So city, you know, Stu has access to city, but in this context, I cannot access this member variable. So what I'm going to do is I want to, in my student class, say that this function is allowed to access my private members. So and there we go. So I'm telling the compiler there is this where function. Here's the signature. When you find it, just so you know, it's a friend of mine and it can access private member variables, all of these, and also home address. Whoops. All right, so let's compile this again. All right, I still have problems. So now it's complaining about city. So although address is a friend to student, so city would be accessible to student, and student is a friend to this where function, I do not get the transitive property of having the address a friend to where. So I have to actually explicitly here also make this a friend. Void where okay. All right, well, we still have a problem. What is the problem? Well, it says in address.h, student does not name a type, line 10. So here, the compiler gets here and says, what is a student? I have no idea what you're talking about. So this is technically like a forward reference, right? We've declared that there exists this class called student and it's a friend of mine. So the compiler can say, well, I don't know what student is, but I know it's a class and I'll see it somewhere in the future. But this is a weak forward reference, so it does not extend to this. So here I need to tell the compiler about student. So of course, the first thing you would think is, well, that's what headers are for, right? Okay, so let's compile it. Then the compiler is going to read this. It's going to jump to student.h, going to read all about students. And when it gets down here, it's going to know what a student is. Oh, still got a problem. If I look at the first error, because these errors cascade down here, and these are kind of a result of this first error. Student does not name a type. Still, I've told it about it though. So let's think like a compiler. I'm compiling my address class, let's say. No, where? All right, so I guess let's just go through the thorough one. So here is the command that caused the error. So let's start there. So I'm trying to compile main.cc. And it says include student.h. Great, let's go to student.h. Student.h, I read the header guards. Okay, I'm never going to read this again. I get down to address.h. Oh, I got to read address.h first. I go to address.h. I read, oh, it says include student.h. Well, I come back here and it said, well, I already looked at this file, so I'm not going to read it again. But I've not actually read this student class yet. And so when I get down here, it still doesn't know about it, right? So this is unrelated to friendship, but this is an example of something you might come across either in one of our assignments or in the real world. I have a circular reference here. I have address.h includes student.h and student.h includes address.h, and that can just go around and then, well, the header guards stop it, right, from going forever. But I end up in a situation where only one class knows about the other, and I want both to know about each other. All right, so the solution here is, well, I don't need the full definition. I just need the compiler to understand that there is a class called student. Even though I kind of already declared it here, I need a strong forward reference, right? So this will tell the compiler that student is a class, so you can sort of reason about this parameter. All right, so finally, all the friendship and all the circular references sorted out. This where function finally works and prints out the City of Stu and Joe. All right, questions? Yeah. Sorry, what's that? Yeah, sure. Yes, in this case, a getter would make a lot more sense. But again, it's also the issue of maybe this is just a private class that I'm very specifically using here, and I don't want people to grab even to read. I don't want people to, right? So using the principle of least privilege, if no one else needs to access this member variable except for the where function, then maybe friendship is the right way to do it. Because a getter is public, everybody can use it. But yeah, that's maybe not a very convincing argument. So yeah, getters and setters are, I mean, 99% of the time, that's your solution. You're right. What's that? Yes. This is poor design to illustrate this sort of niche application of friendship. Yes, you're right. Yeah. So the comments are that why wouldn't we just use getters here? And that is absolutely valid. Probably I would never do this. This is just an artificial example to illustrate these concepts. That's all. Yes, getters and setters 90% of the time, 99% of the time, that will solve your problem, and you should use them rather than going into this very complex, sort of relationship with friendship and all this. We're going to see that you do need friendship for operator overloading, but yeah, that is a valid point. If getters and setters solve your problem, use them. That's perfect. Everybody understands them. They work. Yes, exactly. And friendship is not a two-way street necessarily, right? It's I'm friends with them, but they're not necessarily friends with me. That can happen. All right. Other questions? What am I doing here? 35%. Oh, wow. I think my battery is getting worse. Okay. Yeah. So, I mean, there is, sort of a really weird scenario where I want address to be private. Probably better solutions. But all right, so let's jump into static member variables. Yeah, sorry. Cross what? Yeah. I mean,
Because a lot of classes that are applied, why not just put those in the DLL together and only export the things that want to be public publicized?
technically exporting is, I mean, it's not new exactly, but it's newer and not used, not perfected yet, I guess, is at least. Okay, well, I'm not familiar with that, so I don't know.
So that it can be linked.
Well, linking is to source code, so public and private don't really have meaning at the source code level, right? It's already compiled at that point.
Yeah, like public and private in the source code is equivalent to something being exported or not exported to DLL.
Again, I don't know how DLLs work, so I don't know. Other than I know they're a library, but exporting, I'm not sure. Yeah. I mean, it's as far as I understand, it's the same as a .o in a Linux.
Yeah.
But export, I don't know. Sorry, I don't know how that applies. Like, what do you export individual functions or where? Like,
External quotes.
Sure. Because my understanding is that the header determines what you have access to. And then the DLL is the compiled, which, I mean, access is already determined at that point. So header determines like what libraries I can call. You can't, I mean, there is no, or maybe I'm wrong, but I don't know. Yeah, we'll talk about it after. All right. Static member variables. All right, so yeah, so in general, right? So I can have a class. I have instances of the class, and those instances have their own member variables. But I can also have, well, specifically talking about member variables, I can also have static member variables. So that means I have one instance of that for all classes. And then we can also extend that same idea to functions, right? So I can have a static function, which of course, there's no such thing as multiple, I don't have instances of functions, but I have a function that I can use even when I don't have any instances. So we're going to make static members using the static keyword. Static members are properties of the class as a whole. Must be initialized at file scope. And in fact, that's even not quite accurate. You have to, well, we'll talk about that when we get there. The static keyword is a little bit tricky because there's multiple contexts it can be used in. One is that if we declare it at file scope, it limits this to a global variable that can be used within that file. But here we're going to use it in the class declaration. So we're going to use it in the header and not in the source. All right, so here we have a book class. And well, it's just very simple. We have a title and author. We also have an ID because we're tracking it. Maybe we're a library or a bookstore. So when we make a book, we're going to give it an ID. We want that ID to be unique. So we're going to make a bunch of books and print them out and then talk about maybe a better way to do that. Sure. All right, so declaring and initializing books 1 to 4, and then each book has a unique ID. The problem here is that I am tracking these manually, and that's error prone, right? So now I have to keep track of the last ID that I used every time I want to add a book so that I can assign it a new variable or a new value. I have to keep track if I have multiple locations for my library. And so I want these to be unique across locations. Well, now I have to like communicate with these other locations. And so I want all this handled programmatically rather than manually. And so we're going to use a static variable for that. So yeah, next ID is static. I use the static keyword here. It's still private, right? So we still have the access modifier still applies. And now in my book constructor, instead of doing this, I kind of want to do something like this. Assuming I have a next ID variable, I can just do that. And then also, I want to increment it every time I use it, right? So now this is automatically going to track the ID of my book, which means that I don't have to have this in the constructor. And yeah, and then here also, so declaring and initializing books 1 to 4, so this should all work. Well, not quite. All right, so the complaint is, well, all right, let's clean it and make it again. All right, so warning relocation against blah, blah, blah. So this is sort of difficult to parse, but what it's really saying is that I don't have in my, so the same way that I need sort of an implementation of my function, I kind of need like an implementation of this variable. Generally speaking, we're going to use this opportunity to also initialize it, right? So int book next ID equals 1, right? So what we've done is we've declared that there is a next ID variable, but also we've assigned it the value 1 using the scope resolution operator to tell the compiler that this is not a global variable. This is a static variable inside the book class. So it's subject to all the access modifiers and whatnot. All right. So now everything works exactly the same as before. Each book gets a unique ID, but now I don't have to remember them or control them. And yeah. If I don't, and as you notice, if I don't include this, even if I don't initialize it, I still have to declare it here, which is, well, kind of unexpected. It's something I just learned today, actually. I always thought it was an initialization step, but it turns out if you do not include this whatsoever, then you have problems with the compiler finding that, that variable. So here I did not initialize it. Luckily, it's initialized to 0. But I always, whether or not I initialize it, I have to declare it at file scope in my source file. Like questions? Might be so that I can use it in this function, but I'm not sure. I'd have to look into that. Regardless, okay, so that works. Let's say down here I want to next ID. So I want the value of this next ID variable, only it's private. So, well, we can take care of that. We can static int get next ID. All right, so I'm going to make a static function. Now this static function can be accessed from, well, any class. So I can say b1 dot, or any instance of the class, get next ID. Right, so my next ID is 4. Oops. Should be initialized to 1. So there we go. Next ID is 5. On the other hand, maybe I want to see what the next ID is up here. Well, I don't have B1 up here, right? I have not created it yet. But since this is a static function, I can say, well, just run this function anyway. I don't need an actual object to run it on. I can just run it on the class itself. And so initially my next ID is 1, and then down here the next ID is 5. So yeah, those are static variables. You're not expected to use those in assignment 2, but in assignment 3, there will be a bunch of static stuff. There's no ID associated with a specific book. I'm not sure what you mean exactly. So each book has an ID variable, but this is like the sort of the counter for the entire class, right? So the entire class uses this next ID variable, but each individual object has their ID assigned to this variable. So I'm not sure if that sort of answers your question or not. Yeah. Other questions? Okay. Be careful of the static keyword, right? So important to note, we used static here. We did not use it here. We used the scope resolution operator. Technically, I think we talked about it before, but static means a global variable that is sort of local to this file scope. So you can use it in this context, but okay. All right, so yeah, just be careful of the syntax. I believe that takes us to the end of this. Let's do a quick woo clap. Oh, did I do the wrong one? I did. Yeah, that's fine. Okay, we'll try to go through these a little bit quickly, so make sure you get your answers in quick. Yeah. So I always check because every time a new compiler comes out, of course, I say something and it's wrong, but I tried it in the last class and that doesn't work. So there's some, for whatever reason, it doesn't let you do that, which I don't know if you had a header-only implementation, though, maybe it would allow it. I don't know. You might still have to do it at file scope. But yeah, that's a good question. So yeah, the question was, can we initialize this right here? And the answer is no, right? You can do it consts, I believe. If you make this const, you can, I think that would work. Of course, this is going to cause a whole bunch of other problems, but yeah, for whatever reason, you can't do this. Yeah. Static inline, yeah. Okay, well, yeah.
If you have a static const,
Probably, yeah, I'm sure. Yeah.
Static define blank. You declare constant ID equals next ID.
Sorry, could you repeat that? Yeah.
Zero. Then if you have a constant int ID declared as equaling, say, next ID plus plus.
In like just in the header file directly. So if I did something like this, oh geez, I don't know. Yeah. No, I understand. This is going to cause I would have to set up. There's a whole bunch of stuff I'd have to change to get that to even compile. And I don't think we have the time. So yeah, that's an interesting idea. Can I? I don't know. I'd have to try it out. Yeah, that's a good question. All right, let's jump into woo clap. We got 5 minutes. Oh my God, is this already done? All right, reset event. All right, sorry everyone, if you could, maybe we won't get through this today, but if you could sign in again very quickly, we will jump through these.
What we did last time?
What's that?
What was we did last time?
This woo clap? Oh, did I choose the wrong one? I'm like, my mind is half on. Oh, did I do software engineering? Oh, that's why. Oh, no, I just deleted everything. All right. Well, you guys are lucky. Everybody will get this one for this class. Sorry. You're right. So just to explain myself, software engineering is the one we did last time, and I just deleted the entire thing. So I'll just give everyone the mark for that one rather than redo it. What I meant to do was encapsulation. So I think we're going to leave that for next time. We only got 4 minutes left, but Yeah, sorry, don't worry about the woo clap. At the beginning of next class, we'll do that. So rather than, we're ending a little bit early, but that's fine, rather than start an entirely new topic. So again, technically we have nothing due except for assignment 2 is due after the break. I will be around during the break. I don't know if I'll have regular scheduled office hours. I'll let you know. But you can email me and set something up. That's not a problem. I do have office hours tomorrow for anybody who wants help this week. And other than that, have a good holiday. Good luck on any midterms you may have. And I will see you guys in a week, if not sooner. The software engineering, I accidentally reset the entire thing. And so yeah, I'll just give everybody from this section that one. A is friend of B doesn't mean B allows A to. Depends on what you mean by A is a friend of B. So if in A I declare that B is my friend, that means that B gets to access A's member variables. Right, so if the declaration is in A is the one giving access. If the declaration is in B, then B is the one giving access. Yeah, the semantics, I should, yes, in English, it's obviously easy to get them mixed up, but so I guess that the better way to say it is that A grants friendship to B, right? Or something like that. Yeah.